At this point, we know what the iterator pattern is. Let's now take a look at the different kinds of iterators that can be offered to us. Again, we'll be working with examples in Java. There's also a little bit about Python iterators at the very end, just so that you get a complete picture. Now, I've been using both terms here, and I've been using it carefully so that you know there is a difference, but let's just focus on that for a minute. It's important to realize that in Java, an iterator is a separate object from the iterable, which is the collection. So the iterator and the iterable are different and separate objects. The iterable is the collection. So the collection implements iterable T, the generic interface, and provides a way to get an iterator. Let's look at an example so that it really becomes very, very clear. So you have the iterable interface, and the iterable interface allows you to return an iterator. An iterator is also generic. So iterable T has one method which gives you an iterator T. And the iterator T is a separate interface which allows you to loop over the elements in a collection. It has the three methods hasNext, next, and remove, which allows you to deal with the elements in a collection. To summarize, the iterable is the collection, or rather the collection implements iterable. So the collection is the iterable. The iterator is an interface allowing you to loop over the elements of a collection. It was important to focus on this difference in Java because it's totally possible that the collection itself might be an iterator. That is totally fine. What does that mean? It means that the collection itself might provide a way to iterate over its elements. This brings us to the difference between internal and external iterator. If the collection itself is an iterator, it's an internal iterator. And if the iterator is a different object, as in Java, then it's an external iterator. When the collection itself is an iterator, it means it's the collection which specifies how to iterate over the elements that it contains. It's not an external object which specifies how to go over the elements in a collection. It is the collection itself. Not really clear? Let's look at some examples and see what the advantages and disadvantages of internal and external iterators are. Let's first look at an external iterator because that is the standard which Java uses. Let's look at this list of alphabets that we've got. It has A, B, C and D, or rather A, B, D and D. Now, you simply can iterate over these alphabets using a for loop. We know that the for loop or the for each loop under its covers just uses the iterator for that list and iterates over each of its elements. It is this under the covers iterator which specifies the order in which the elements are to be returned as a part of the for each loop. Let's look at the second example. Here we directly use the iterator rather than a for each loop. So you get an iterator object called iterator saying alphabets.listIterator, and then you keep checking for hasNext. As long as another element is present, you iterate, you get that element and you perform the to uppercase operation. In both these cases, it is the iterator object which specifies what element to return next, the exact sequence, etc. It's in the hands of an external object, that is the iterator. Let's look at an internal iterator. Now, alphabets is still a list. A list provides a method called for each, which basically takes in a lambda or a single method interface to indicate what action you want performed on every element in the list. Note that it's the list itself which is specifying the sequence in which the elements are iterated over. It's not an external object. The list itself is the iterator. All you have to do to work with this iterator is to specify what is the operation you want performed on every element in this list, which in our case is the 2 uppercase. So we just specify how we want to modify or deal with every element in a list or a collection, and the actual iteration or the actual sequence of elements is hidden within the collection itself. This is an internal iterator. So how do external and internal iterators compare? What are the pros and cons? External iterators have this advantage that because the iterator sits outside the collection, you can define multiple iterators for the same collection. So you don't just iterate over the collection in exactly one way. A collection can have multiple iterators. Each of these iterators can specify the sequence of objects differently. Let's take an example. For example, forward and reverse iterators. Forward iterators iterate over a collection in one order, say from 0 to 10. Reverse iterators iterate over them backwards from 10 to 0. These are quite standard in libraries, such as the standard template library in C++. You can totally imagine that you want to be able to specify how to iterate over a collection. In that case, you'd specify an external iterator. However, internal iterators focus on what has to be done on each element. They abstract away how you iterate over the elements in the collection, the exact sequence that you follow. So the internal iterators help you focus on what has to be done to each element rather than how the elements have to be iterated over. Iterators work on all collections. They do not require the underlying collection to be ordered. So, like I said, lists are ordered collections. Doesn't mean an iterator needs to work only on a list. Sets, maps, all of these are unordered collections. The elements in a set or a map are not in any specific order, but they can be iterated over as well. So iterators work on all collections. You can treat ordered and unordered collections in exactly the same way and go over its elements one by one in a sequence using an iterator. Let's speak about the last method that's available in an iterator interface. That is removal. The Java iterator interface allows removal of elements from a particular collection. So it's totally possible that you have one iterator which is walking over the elements in a collection in some sequence, while another iterator on another thread goes through the same collection and removes elements from it. So you have multiple threads. One is just reading a collection and walking over its elements one by one, and another is actually modifying that collection and using an iterator to remove elements from it. What does this mean? Yes, threading and concurrency issues. Basically, threading and concurrency issues related to containers tend to be a very big problem, and you have to deal with them carefully. We won't talk about how here, but needless to say, you have to be very wary of when you have multiple threads working with containers and they're performing both read and write operations. We've spoken a lot about iterators in Java. The Java collections framework is a very rich framework which allows you to do all kinds of operations with collections, which is why iterators in Java are so interesting. all of this class, we focused on Java's iterators. However, there exist other languages as well, and they have interesting support for iterators as well. Let's take the case of iterators in Python. It's worth a special mention. We won't dwell too long or too deeply on iterators in Python. However, since Python fundamentally works in different ways from Java, it's somewhat functional while Java is purely object-oriented. Java does have its functional aspects in terms of lambdas, but it's kind of an afterthought which has been built later. Python is somewhat functional to start with. This means that Python codes tend to have far fewer for loops and far more lambda functions applied to lists. The general way of programming in Python is to use lambdas and apply them to all elements in a list. This is only possible because of the rich iterator support in the Python language. Let's quickly look at what this rich iterator support is in Python. Let's take a look at an example in code to see how iterators in Python behave. The use of iterators is very common in Python, and in fact, any list-like object can be converted to an iterator. The example that you see on screen is a string containing ABC. A, B, and C are the characters in this string, and this string you can just have an iterator over the string by calling iter_s. It is the iterator. You can access every character in this string by simply calling next on this iterator. So there you see A, B, and C, and once we've reached the end of the string, when you call it.next, it throws a stop iteration exception. So you see, it's really easy to use an iterator on Python, and you've basically defined an iterator over the string by just calling the iter function. This is the basic built-in iterator. Let's now take a look at how we can build a reverse iterator in Python. We define a class named reverse. This has the init, which initializes the class. We specify the data, which is the list over which we want to iterate. And we specify that the index is the length of this data. See the __iter__. This just returns the class itself as the iterator over the list. This is the reverse iterator. Now, next is the method that the iterator has to implement. It basically checks whether we've reached the last element we want to iterate over, which is at index 0. Remember that this is an iterator which is reversed. That is, it's a reverse iterator. It wants to go over a list backwards. So if the index is 0, it basically throws the stop iteration exception. We've seen that earlier when we used the iterator, that when we reach the last element in the list, the stop iteration error is thrown. Then the next step is it basically decrements the index starting with the last index and returns the element present at that index. That's it. We have a reverse iterator. And you can see a use of this on the word spam. You can just say you want iter reverse. Notice how we pass the reverse iterator in. And when we use a for each loop over reverse, it simply prints spam backwards as maps. Okay, that was a whole lot about the iterator pattern in Java as well as a little bit in Python. Hopefully this has given you a very good idea about how the iterator pattern is used, how you can make your class an iterable and use it with for each statements.